Okay, we're going to be looking at 1.5b now. So we've been looking at polynomials and what they are, so what are they made of, those monomials, how to find the degree of a monomial, which is the sum of the variables exponents, how to find the degree of a polynomial, which is the largest monomial degree. So we've got to figure out who's in charge there. And then we looked at some operations of polynomials through addition, subtraction, and multiplication. So now what we want to do is rather than expanding, let's say, polynomials, what we want to do is factor them. And so, in other words, the polynomial is given without parentheses, and we want to create them. So remember, factoring is simply creating bubbles. So it's the bubble making business. So creating bubbles. And what I mean by bubbles is parentheses of some sort. So it could be, let's say, something in front, but there's a bubble. It could be two bubbles. It could be a little bubble and a big bubble, or it could be multiple bubbles. So like three bubbles or so. So that is what factoring is creating a product to where each of the factors are going to be prime. In other words, you can't factor it anymore. So we're breaking it down, prime factorization, but with polynomials rather than with numbers is what we're doing. So the steps that we're going to be taking to factor is a good sort of rule of thumb is always look for the GCF first. Now, if you don't, you could still find it later, but you may have to trust me on this, is that it's much easier to identify the GCF first than it is to identify it once it's in a factored form. So let's go ahead and just start with that. Any problem we have, the first thing you look for is the GCF. Okay, the first thing we look for is a GCF, which stands for greatest common factor. Okay, so if you want to write that down, you can. So we always look for that. If it has it, pull that GCF out in front of a polynomial. So if we have something like 2x plus 4 and they want us to factor, what we do is we look and we say, is there any factors inside of each of those terms that's common? And so what we have is we have a numerical factor of 2 that's common. And so we can factor out that 2. And then what we have left is the x plus 2. So it's a reverse distributive property kind of thing. It's distributive property, but in the other direction. So factoring itself is not really a property. We're utilizing the distributive property, but in the other direction to create a product is what we're trying to create from a sum or difference. Now, once we either take the GCF out or we don't, then I think a wise question is, how many terms am I dealing with? We've got to get organized in our minds because there's a lot of different ways to factor things. So GCF first, and then how many terms am I dealing with? So like here, there's 2 terms. Okay, so the GCF is out front, and then what I have is I have 2 terms. So when I say how many terms am I dealing with, we're talking about the factor that the GCF was removed from. If we had something like x squared, let's say plus 3x minus 4, then when we look at something like this one, we'd say there's 3 terms. And so that's going to be a different process than if it's 2 or if there's 4. Okay, so we really have to get into one of those categories and get organized in our brain. So first thing we got to do anytime we're factoring is that we're going to take the GCF out first. So number 1, take the GCF out. Then once we do is we ask the question, how many do we have? And then what we have is we have either 2 terms. So that's this one right here. So it could be 2 terms. It could be 3 terms, which is a trinomial. And that's a different method. Or it could be technically 4 or more terms. That's why you don't see a name up here. But this is 4 or more, so greater than or equal to 4. Typically, it's 4 if you have one of those that you do by grouping. And then what we have is sort of a special one, which is if you have fractional exponents. So rational exponents, so something like x to the 1/2, if you see something like that as one of your terms, then we need to look at it. But most of the time for that one, what we're looking at is it's going to fall into 2 categories. It's either going to be what we call a polynomial-like equation or a quadratic-like equation. And so we're either going to do GCF on that, or we're going to use something called a substitution. We'll use like what we call a U substitution. It doesn't matter if it's U. You can use whatever variable you want, but we're going to use a U substitution, or a GCF on those really sort of crazy ones. So this one right here is probably going to be fairly new to you. You might have seen it, definitely in pre-calc we've seen it, maybe in Algebra 2, but most of the time in Algebra 2, we focus really hard on the first 4 methods and not the 5th one. So here we got to just do them all. So the method 1, greatest common factor, GCF. We've already talked about it a little bit. Let's just look at the example down at the bottom where we're going to be sort of reversing our distributive property. So how I start these is looking at the numerical factors first, and then look at your variable factors. So 12, 8, and 4, we want to find now, remember, it's the greatest. So 2 definitely goes into all 3 of those. 4 is actually in all of those as well. So it's like, how do I know which one to choose? It's the greatest or the largest of the 2. So we're going to take a 4 out of those. Okay, now let's go ahead and look at our x's. And what we want to do is we can only factor out the smallest number. Now lock that in, okay? It's the smallest exponent. This is going to help you with method 5. Okay, we'll come back to it when we get to method 5. But if you can remember, I can only take out the least number I have. Okay, so this is one of those, this is like a life lesson. You shouldn't be taking more than what you have, okay, kind of thing. So the first term has 4 x's, the second one has 3, and the third one has 3. So we can't take more than 3. So even though the first one has 4, the other 2 only have 3, so I can only take 3 of them out, which simply means I'm going to have an x left behind in the first term when I get ready to write that. Let's look at our y's. Y's, what I have is 2 there, 2 there, and 1 there. And I can only take out 1 because the very last one doesn't have enough. So the other 2 will have some leftovers, which is fine. And so we'll go ahead and get this now factored out. So when we do factoring, the other thing you might want to consider too is whenever we talk about this idea of factoring, factoring is simply division. Okay, so think about it. When we distribute, we multiply. And so if we're doing the reverse operation of that, then what we're going to be doing here is we're going to be dividing. So we're taking whatever we start with, and we're going to divide by what we removed. Okay, so think of it reverse, we distribute, we'd multiply. But factoring is dividing it out. So 12 divided by 4, okay, is 3. Then what we do is we have x to the 4th divided by x cubed. Now, another way, instead of just thinking division, that's what it is. But how many have I removed? Well, I removed 3 of the 4, so that means I have 1 x left, and I have 1 y left. So sometimes that's easier to look at it like that, but technically we're dividing it out. Go to the second term, 8 divided by 4 is 2. Y cubed, or excuse me, x cubed, we took all the x's out, so there are no x's left. And it looks like I took 1 of the 2 y's out, so I should have a y left. Now, numerically down at the last one, if you notice here, we took the 4 out, we took the x cubed out, and we took the 1 out. Now, this is where some students I lose because they're like, oh, you took everything out, so it should be 0. The only time we get 0 is when we subtract things, okay? So like if I removed it through subtraction, but we're not removing things through subtraction, we're removing it through division. And so what I'm doing is taking 4x cubed y and dividing it by 4x cubed y, which means I should have a 1 left behind. If you start with 3 terms, then in your factored bubble, there should still be 3 terms. If you're unsure of yourself, distribute this, and you should get back to where you started. Check yourself, check your work, and that would be fine. But I do have students sometimes that go, oh, it's all gone, so it's a 0. It's division, not subtraction, so it's never going to go to 0. It's going to go to a 1 if you remove everything. So that is GCF. Let's look at another example. Again, work ahead of me if you feel like you got a grip on this. And so we look at the 3 terms, and we say, well, what's common in these 3 terms? And it looks like a 4. Are there any x's common? Yeah. Well, how many? Well, I got 5, 2, and 3. I can only remove the smallest number. That's a good important thing. Now, there's nothing else. Now, this one has z's, but the other ones don't. So I can't remove any of the z's. Now we go through and we divide. 12 divided by 4 is 3. I remove 2 of the 5. That means there's 3 x's left. On the second one, notice I removed the entire thing. So I have a minus, but it's not 0. It's going to be a 1 there because it's 4x squared divided by 4x squared. Then 8 divided by 4 is 2. I removed 2 of the 3 x's, and the z's have just been sitting there the whole time. And so there's our GCF form, factored form. Okay. Another GCF, a little bit different looking. So I want to make sure to go through this with you and let you see it, because we have a tendency to want to like distribute the 3 and -3 and look at things there. Slow down and look at this. And if it says solve by factoring, especially if they even say the GCF here, we look and what you'll notice is this factor, which is prime, and this factor, which is in the other term. See, we have two terms, one term, and then if you include the 3, that's our second term. So what's a common factor in both those terms is the bubble itself. So we can factor out the GCF a squared minus b since it is common in both the first and second terms. Now, when I do that, I've got to ask myself, what did I leave behind in my first term? Well, I took the whole thing. It's not 0, it's a 1 again. And then over here, I took, again, the bubble out, but I left a 3 behind. And then hopefully you can recognize to clean that up. And I like putting that -2 in front. That's just a personal preference. Don't think you have to. Okay, but there we go. And there's our solution to that one. So rather than going through a long process of distributing, combining like terms, and then doing a GCF, if you can recognize immediately there may be a GCF, just it's a quantity, that would be big. And that will come into method 5 as well, this idea of a GCF being a quantity. Let's go to method 2, factoring by grouping. Now, what we have for factoring by grouping is when we have 4 or more terms. And grouping, what we're going to try to do is simply use parentheses to group the first 2 terms and then to group the last 2 terms and see if there's GCFs with just 2 instead of 4 terms. Now, if that doesn't work, you may have to rearrange the order of the polynomial. And that may help. It may not. It may be that it's just a prime polynomial, but we may have to rearrange it so that we can find some GCFs. But this is when we have 4 or more terms, we're going to end up using GCF. So we look and I go, oh, I have, first off, is there a GCF common in everything? No, there's an X in a couple of them, a Y in a couple of them, but nothing that's common in all 4. So I always check GCF first. How many terms do I have? 1, 2, 3, 4. 4 or more terms we want to do grouping. Now, I want to show you, I can see it, and maybe you do too, but I want to go ahead and group as it sits. So this is how they gave it to me. So I'm going to go ahead and just group like this. Now, what I want to do is make sure that I leave either a minus or a plus sign here in between because I don't want to change this to a multiplication problem. So in other words, when your parentheses are right next to each other, that means multiplication. And I'm not doing that. What I'm doing is just grouping things so I can look for GCF. It's just a strat. I don't want to change its value at all. And there's different strategies when this is a minus sign in the middle. So we'll talk about it when we get to it. But with a plus sign, you don't need to worry much. If it's a minus sign, you either got to do one of 2 things. If there's a minus sign in the middle, you either got to change the sign or signs if there's one. So you're going to change the signs inside of your second bubble because it's like factoring out a negative. Or, if that's not a way that you're comfortable with, if you do see something with a minus sign and you have some term, what you can do is just move this negative x down. So I'm just going to show you, like, let's say we had other terms out here, but you can move that negative x down and then put a plus sign. So it looks like this. Then when you group, that's fine, but you'll probably have to factor out a negative at that point, so a GCF of a negative. So if you feel more comfortable or learned it that way prior to this class, moving it down, that's perfectly fine. You don't have to do it my way. You just have to do it a right way. So that would be fine, and I can help you with it if you have questions. But let's go ahead and jump in. So we look at this, and I look at these 2 terms, and I say, is there anything common? So I'm looking for a GCF there, and there isn't. That should be your indicator that this was not grouped well. And then I look at the second one, there's nothing common. So what I'm getting at is the way it was sitting was not really the best way to group this. So I'm going to use commutative property and reorder this a little bit. And you can reorder this really however you want as long as the positives and negatives are attached to the terms you're talking about. So I'm going to actually put 15x first. And then I notice there's 15 and 5 and x are sort of common. So I'm going to put those 2 terms together. And then I'm going to put the 3 minus y second. So now when you group, It's a plus sign, so I don't need to change the sign here. Now notice there's a GCF of a 5 and an x, and I'm left with 3 minus y. Over here, there's nothing to take out. However, it doesn't mean there isn't something in front of this bubble. It means there's a 1 times that bubble. So even though we don't put the 1 there, it's there. So keep that in mind. Because now what we want to do is notice that in these two terms, the bubbles are the same. So think back to the problem we just did just a little bit ago with a GCF. So let me backpedal a little bit. That one right there. When the bubbles match up, that's a GCF. So we can factor out the bubble. And so we're going to take the 3 minus y. Sorry, pen didn't work very well on that one. So 3 minus y and factor it out. And then I should have something left behind. So when I remove this and move it out front, I'm left with 5x. And when I take this one, this is why I like putting the 1 there, and move it out front, then what I'm left with is a plus 1. And there's our factored form. So we have 4 terms. We can factor it to a double bubble kind of thing. Okay, let's look at another one. You can immediately see this is not grouped very well, so we're going to regroup. I'm going to put the negative in the middle so we can practice one of those. So I'm going to move the 2x right here. I'm just going to slide the negative y over, and this should be a good way of doing it. But this will give us a chance to look at what happens when there's a minus sign in the middle of the problem. So let's go ahead and group. Now, this is how I do it. I leave the minus there. I just have learned this, and you can do the same. When I do a grouping symbol like this, my negative y, now if you look inside, it's a positive y, so I changed its sign. So I must change the sign of the 3xy. Technically, what I just did when I grouped it like this is I factored out a negative. And anytime you factor out a negative, you need to change the signs. Now, here's your alternative. If you don't like that or that doesn't make sense to you, that's perfectly fine, is to scoot down the negative y and put a plus sign in. So like this, I scooted it down, you group, so it looks like this, and we still do the same thing with everything up front, so nothing there changes. But now what we have is, now what we want to do is factor out a negative, and then that should change my signs. So it looks a little bit like this. Now, compare these two, and you can see they're identical to each other. So again, it just depends on what you're more comfortable with and what you do consistently well. I'm going to go ahead and factor out that 2x kind of thing like I did over on the right-hand side. And so what we have here is, and then over on this one, there's nothing to factor out. But remember, what's in front of the bubble is a 1. And so if it helps, put a little -1 if it helps you. But now what we do is we look at the two bubbles and we ask ourselves, well, are those two, let me back up a little bit. Man, hopefully you were yelling at me a little bit on the video. There is a GCF in the second bubble. That's the bubbles didn't match up. There's a Y. So I need to make sure to get that Y out. So my apologies. Okay, but now we can go ahead and we get 1 plus 3x, okay, something like that. Okay, so now what we do is we look at our bubbles, 3x plus 1 and 1 plus 3x. Now I know, again, they're not identical to each other, but using community property, aren't they the same? I can change the order of addition problem, it doesn't matter, so I can flip either one of these and it's the same. So my bubbles are the same. So this takes us back to that GCF again, where I'm going to take and factor out now this bubble. So I'm going to have a 3x plus 1 that I have factored out. And then what did I leave behind when I removed those? Well, I have a 2x in my first term, and then I have the minus y from my second term. Right there and there. And so there is our factored form. So 4 terms hopefully takes us to double bubbles. Sometimes 4 terms is, you can't, even if regrouping it doesn't work, and that just means it's prime and you can't do anything with it, you can't factor it. So a lot of times you're going to be able to factor, but once in a while you won't be able to. Let's keep moving on. Now we're going to look at 2 terms, so method 2. So if we're talking about binomials, so 2 terms here, there's going to be 3 options. Okay, now let's do a review since we're moving into a new thing. What's the first thing we always look for when we factor? GCF. Once we either take the GCF or establish there isn't one, then the next question is how many terms do I have? If you have 4 terms, you're going to look to group, and then you do a GCF. Okay, so a lot of GCFs, but the grouping. If there's two terms, you have three options. It's either what we call the difference of two squares, the difference of two cubes, or the sum of two cubes. Now notice there is no sum of two squares. That is not real. So we do not factor the sum of two squares, only the difference of two squares. And so what we mean by the difference of two squares is, could I write my polynomial as something squared minus something squared? Now, instead of using a and b like this, a lot of times in Algebra 2, I'll use bubbles. And I'll say this is the template. If you can fill the template with values, and it's the same as your polynomial, then it's the difference, subtraction, of two squares. So that's what the a and the b represent, is what you find here is your a and whatever you find here is your b. And then the formula for the factoring formula is simply a plus b times a minus b. And that those are conjugates. So they go to conjugates. It makes sense because when you flood this, you get a squared minus b squared, which is our difference of two squares. So we got to figure out what is our a and what is our b so that we can go to conjugates and do a plus b times a minus b, which can be written as a minus b times a plus b as commutative property again. So we'll look at some of those. Also the last two. Now the last two we sort of remember together, okay? So we sort of memorize these together. And these are a little bit more complicated looking, but we still use the templates. And in this case, instead of squares though, we're gonna use cubes. So I'm gonna put a plus or minus sign here because we're gonna do them both. We're gonna memorize them both at the same time, okay? So it's gonna look something like this. So when we see cubes or something that could be the sum or difference of two cubes, what we want to do is we want to remember that how we factor this is we're going to go little bubble, big bubble. So we're going to put a little bubble, which is like a binomial, and then a big bubble. Then what we want to do is we want to go keep the sign, change the sign, always plus. Now, what I mean by keep the sign is if you started off with a plus sign, so if your polynomial is an addition, then you're going to put an addition. If your polynomial is subtraction, then you put a subtraction. Okay, so you can see that on the separate factored form. So keep the sign, change the sign, goes here. So you can see when this is minus, this is plus. When this is plus, this is minus. So it goes little bubble, big bubble. Keep the sign, change the sign, always plus. Okay, so it's always plus for both of them. You can see that there and there. Okay, so that's where we're at right now, is when we see the sum and difference of two cubes, we want to think little bubble, big bubble, keep the sign, change the sign, always plus. Then what fits in is we have a, b. So we got to figure out what cube gives me whatever's there and what cube gives me the b value, the b cube. And now we know what a and b are. So for both formulas, it goes little bubble, big bubble, keep the sign, change the sign, always plus. A, b, a squared, ab, b squared. And so now we've memorized both. Now be careful with the b squared and the a squared, because if you had, let's say, 2x as your a, if 2x is your a, this is not 2x squared. That is not 2x quantity squared, it's 2x squared. But if a is 2x, we've got to make sure that we're squaring all of a. So we square 2 and x. So be careful on the a squareds and the b squareds to make sure we get the right values there. Okay, so let's go ahead and look at some examples of our factoring. So factor the following polynomial. What's the first thing we always look for? GCF. We look, there is anything common. It's two terms. So again, the question is how many terms do I have? Two. So that means it's either the difference of two squares or the difference of two cubes because of the minus sign. So the square sort of gives it away. So I'm going to use a template. And if you already are like, I got it, I know what my A and B are, then just skip ahead on the video. And then what we want to do is we want to go ahead and figure out what is our A and what is our B value. So what squared gives me 49 is 7, and what squared gives me x squared is x. So now I know what my A value is in my formula. What squared gives you 9? 3. What squared gives you y to the 6? Y cubed. And so now I've got my B value. And then we just got to memorize the formula, which goes to conjugate. So it goes A, 7x, plus B, or minus if you want to do minus, but I usually do plus first. And then what we do is we do the conjugate of that, which is 7x minus 3y cubed. Now, just because we factor once doesn't mean we're done. So you're always looking to factor. So we're in the bubble popping business. And so what we want to do is we want to look and see, can I pop any of these bubbles? Neither one can be popped, so we're done. They're both prime, but we're always constantly looking to see if I can factor again. So I got another example. It says factor the following binomial. We look for a GCF. There isn't one. We have two terms. Now, the only chance we have of factoring this is the sum of two cubes, because there is no sum of two squares. Or this could be prime, but what we want to do is we want to check. If we want to know if it's prime or not, what we do is we go, well, let's do a cube and let's do a cube and let's see if we can figure out an a and a b. So what cube gives me 27 is 3. What cube gives me a to the 6 is a squared. And what cube gives me b to the 12th is b to the 4th. So I definitely know my a. And then c is my b, which is funny. Okay, so we've established that. Now what we got to do is factor, and it goes little bubble. Man, my bubbles, the pen is not working well with the bubbles. Okay, so little bubble, big bubble. Then we go keep the sign. So we started, that's what I mean is right here, we have a plus sign. So keep plus. Then it goes keep the sign, change the sign, always plus. Then what we're going to do is we're going to go ahead and put our a's and b's in. So what is our a? Our a is 3a squared b to the 4th. Woo, barely fit it in. And then our b is c, so it goes a, b. Now, here we go. A squared. This is our a, and we need to square it. Okay, so we need to square this thing. So I'm going to put a 9a to the 4th, b to the 8th for my a squared. So that's what I meant by be careful. Don't just slap a squared on something. We want to go ahead and make sure to get the correct one. Then we go AB. So we're going to do a times b. So this is 3a squared b to the 4th times c. And then we have b squared. Now what it is c squared because our b is c. That's funny. And there we go. Now, a couple things. Once you get here, the trinomial is always going to be prime. So even if it looks like you could factor it, you won't be able to. It's prime. So don't waste your time. Now, once in a while, for the difference of two cubes, that one right there, or maybe the sum of two cubes again, but for most likely, that one could be factored again. So you want to always be looking to pop another bubble. So be in the bubble popping business. Okay. Last one we'll look at is one like this for the sum and difference two cubes. And so what we have is 64 minus a quantity. So notice here is our b. They've already told us what our b is because remember on our template, it's something cubed. We got something cubed. Our b is the quantity x plus y. Now, if I have to figure out what my a value is, my a value ends up being 4 because 4 cubed gives me 64. So now I know what my a is. I know what my b is. This should be the difference of two cubes. So we should go little bubble, big bubble. Keep the sign as a minus sign. Change the sign, always plus. Then it goes a, which is 4. And then my b is the quantity. Now this is where it gets tricky. Okay, you want to make sure if it's a quantity, put the quantity in like this, or make sure that you recognize you're going to have to distribute that negative through. Okay, so use a bubble for the quantity. You're fine. And then we got a squared, so we get 16, 4 squared. And then we got a times b, so 4 times x plus y. So we're going to need to clean that up just a little bit. So 4x, and we're not going to go super far here. Sometimes they'll even let you leave it as bubbles when you put it in Hawk. So, and then we got b squared. And so here, what we have is the quantity x plus y squared. So if you think of Hawks, they're definitely gonna I think they'll take this right here if you type that in. They're definitely gonna take what I have written next, but it's just really long is all it is. So I have to end up foiling or expanding because we never take an exponent across a plus or minus sign. So help you God, you would owe me soft snickerdoodles if you do. And so we get to something like this, and our huge bubble here has no like term, so it's done. And our trinomial right here is prime, so it's done. So there we go, another cube one. Okay, moving on. Okay, so here when there's going to be 3 terms, I like using the method bottoms up. You might be used to AC method. So whichever one you're more comfortable with, but we're going to use bottoms up. It's a little faster once you get it down. And so that's what I'm going to teach. But if you like AC, I can work with you on that. There's nothing wrong with it. It works as well. AC method is simply pulling apart your middle term so that instead of having 3 terms, you have 4. So you can group, because 4 terms, what do? You group, and then you do GCF, GCF, check your bubble GCF. And so what we did earlier with the 4 or more terms is what the AC method is. Both of them, we need to stay organized. And I like using a factoring X to stay organized. And I don't demand you to use a factoring X. You just need to make sure you know what you're trying to find. And so what we do is we do whatever the A value is. Okay, so make sure. So in a quadratic, let's say, so it's 3 terms. Our A is the quadratic terms coefficient, and then our C is the constant. So we're going to do A times C and figure out what that is, and that goes on top. And so what we want to do is we want to put whatever the B value is at the bottom. And our goal is to figure out what are factors of AC that would add up to be B. So we want to find 2 numbers that multiply to be whatever number we have for A times C. But when we add those 2 numbers, it adds up to be B. Okay, so that's what we're looking for, is a number and a number. And then what we do is whatever our A is, this is where bottoms up comes in, we put A underneath those 2 numbers, and I'll show you how to do that. But once we do that, we can simplify. It's almost like fractions here. So we can simplify the fraction there and simplify the fraction there. If there's a denominator left, if we simplify this, so in other words, if I have something like 3 over 6, okay, and I simplify that, I get 1 over 2. So notice I still have a denominator. This is where I do bottoms up, because I have something in the bottom that I'm going to move up. If there's nothing in the bottom, if there's a 1, then you really don't even need to use bottoms up. You can go straight to your double bubble and go from there. So as we work through these, hopefully that looks familiar. I know other instructors do it that way as well. So let's look at some really quick ones, really shortcut ones you can almost do in your head, but we'll just starting off just real basic here. So my A is 1, my C is negative 12, so we're going to do A times C, which is negative 12, and adds up to be positive 1, which is my B value. So I got to think of what 2 numbers can multiply to be negative 12 to add to 1. Doesn't matter where you put them, the order you put them. And so it looks like positive 4 and negative 3 would work. And then I take my A value and put it underneath. So notice here there's no bottom. If the bottom's a 1, it's almost like not having a bottom. So we can go straight to our double bubble. We put our variable in, both sides, and then we put whatever's right here. So if it's 4 over 1, it's simply 4. And if it's negative 3 over 1, then it's just negative 3. So there's no bottom to bring up. If there was a bottom down here, then I bring it up in front of the x, and that's where we get the bottoms up from. Okay, but for these 2 examples, we should just go straight there. If you want to check yourself, just FOIL it. It should take you back to the original polynomial. Okay, looking at this one, again, work ahead of me if you feel like you remember how to do these. And we want to find factors of 2 that add up to 3. So we're looking at 2 and 1, positive 2, positive 1. My A value is 1, so this is what I call a shortcut one, because there's no bottoms up. Just put your 2 factors in and you should be good. And so we should get a positive 2 and a positive 1. No bottoms up, we're done. Okay. So let's keep rolling. What if we had something where the A value is not 1, though? So that would be considered a little bit less of a shortcut one, and something that we definitely need to get organized with. So we're going to have our factoring x, and we get negative 72. So that's A times C. And I want to find numbers that add up to negative 1, which is my B value. So 9 and 8 stand out to me. I think negative 9 and a positive 8 would work. That multiplies to be negative 72, but adds to be negative 1. But here's the bottoms up. I'm going to take the 6, and it goes underneath each of these 2. So bottoms up's faster, because now what I can do, I don't have to rewrite my function as 4 terms. What I can do is go straight to my double bubble, put in my variable, into both. And then what we want to do is we want to reduce, and you can do this all at once, reduce this. So I can take a 3 out of both of them. So it looks like this, and reduce my second one by a 2. And if you notice, both of these have a bottom. So there's a bottom. So bottoms up, bottoms up. And so what we have is 2x minus 3 now. And then we have 3x plus 4. And if you FOIL this, you would get back to where we started. And there you go. That's bottoms up. Pretty quick. Awesome. Okay. Perfect square trinomials. This one, there is formulas for them. We don't do a lot of memorization of these formulas. So what we do is we recognize if we get something like, let's say, x plus 1 times x plus 1, there's a better way of writing that. Okay, so I think most of you will see that. But that's what we want to do is if I get a situation where I have this as my answer, then what we probably want to do is write this a little cleaner, which means that what we do is we write it as x plus 1 squared, and that's called a perfect square trinomial. But there are formulas, and you want to be, be nice to familiarize yourself with those two kind of thing, whether it's the square of a sum, or the square of a difference. Okay. Okay, the last one is factoring expressions containing fractional exponents. To factor an algebraic expression that has fractional exponents, it's really, we got to identify the least exponent amongst. Remember, we talked about the smallest exponent's the only one we can take out, and this is going to involve more of a GCF is what we have going on. And so we've got to identify what variables are common and how many can I take out. Okay, so look at an example like this one. So don't change what you already know. If I'm going to factor this, I look always for a GCF first. And first off, I notice that there's a 3 common. So let's just start with it and say I can take a 3 out. Okay, so I'm going to have some stuff left over, but we can at least take a 3 out. Now, the second thing is, notice they all have x's. So I definitely can take an x out. The question is how many? So we want to look at the exponents. And I cannot take more than the smallest number. So when I look at those 3, I want to compare them and say which one is the smallest of the 3, which one's further left on the number line, and that would be -2/3. So that is going to be how many I can take out, is x to the -2/3. So now the question is what do I have left over? Now, for the first term, I took the whole thing, and so we talked about that a little bit ago. That's just going to be a 1. Here what we do is we had 6, I divided by 3, and I get 2. Now, again, notice what I just said. I said it quickly, so I want to pause. Division, okay? So when I have x to the 1/3, is what I started with, right? Right here. And I removed x to the -2/3. Technically, what we're doing is dividing it out. So you could rewrite it like this until you get the hang of it, okay? And what I want to explain about this is when we divide powers, if we go back to our earlier properties of exponents, when we divide powers, we take the top exponent minus the bottom exponent. So when we are factoring things out, it's division. And when we divide powers, that means subtraction of exponents. And so what I'm left with now is something that's going to be a little different. And so we add these two. We'll need common denominators. So you end up getting 6 and 3 on top, and plus 4 and 6 on the bottom. So you get 7/6 is what we have. And so that is how many x's we have right there. Then on the very last one, I took the 3 out, so it's gone. But I started with x to the 4/3. So the long way is to look at it like this. And what did I remove was x to the -2/3. And so you do top minus bottom. So in other words, all we care about, we know there's going to be x's left. How many is going to be how many I started with, the exponent I started with, minus what I removed, because that's what the property says. So we end up, in this case, getting 6/3, which is 2. And there we go. We're done with our answer, and we've got a GCF. And we'll be utilizing this later in college algebra, so this is a great skill to master now. That makes your life a lot easier when we get to the equations down the road. Okay. The very last one we look at is where we have a quantity. That's the same as still a GCF here. So we have a term where that and that are the same. So what we can remove is x minus 1. The question is how many? What's my exponent? So we look at the exponents, and I always can take the smallest of the two out. So which one's smaller between 1/2 and -1/2? Hopefully you said -1/2. Now I like using brackets. You don't have to, you can use parentheses here, but I like separating my original problem from my GCF. So I have my GCF out in front, so I'm going to go ahead and put a bracket, but that's a personal preference. Now what we have, let's just show you, is I took this whole thing as my GCF. So I'm going to have -1 over here to the right, because I took the whole thing. It doesn't mean it goes to 0. It's division. It means there's a 1. On the left-hand side, I'm going to have some x minus 1s left over because these are not the same. So the question is how many? What's going to be my exponent? So what it is how many you start with. We started with a half, and then what we do is we subtract how many we removed, which is -1/2. Now, where that comes from, if you're like, man, I do not know where he's getting this, it's what we start with, and we're dividing out the GCF. That's what factoring is division. So we're dividing this out. And when you divide common bases, you simply subtract the exponents, top minus bottom, which is 1. So that tells me my question mark is a 1. Now, we're not quite done, but man, we're close. Okay, now what we can do is, if that's a 1, I don't really need the parentheses around my x minus 1. And so I get this in my bracket, and then you can simplify that slightly. And if you want to go back to a parentheses, that's fine. That's completely up to you. You can leave them as brackets. I'm okay with that. They're both just grouping symbols. And so we get this as our GCF, and then we have x minus 2 as our remaining stuff. And so that's our factored form. And that is section 1.5b.